afternoon, everyone. Welcome to Kubernetes and AWS Lambda play nicely together. My name's Edward Wilde. I'm a core contributor on the OpenFaaS project. It's a thing of passion for me that I squeeze in my free time. I've got 2 young children, so I don't have much of that. I can often be found programming OpenFaaS at the poolside when my daughter's having her swimming lessons. During the week, I get paid to be a platform architect at Form 3. We are a payments platform. I think the world's first cloud-native, SaaS-hosted payments platform that integrates natively with core banking infrastructure throughout Europe. This is what we're going to cover today. We're going to have a quick intro into OpenFaaS. Hands up here who's heard of OpenFaaS. OK, that's great. Keep your hand up if you're using it. OK, well, so hopefully I'm going to ask you at the end of the session if you intend to use it after you've seen what we're talking about here today. We're going to then explore how, as a developer, you can extend OpenFaaS, and that's what I've done to bring AWS Lambda support to the platform. And then to make it useful in the real world, we need to keep running our functions on Kubernetes. That's our preferred platform. But then at the same time, also run part of our function deployments on Lambda. So OpenFaaS began in 2016 by Alex Ellis. He's the project founder. And he wanted to develop Alexa skills because he wanted to automate various aspects of his home, much to his wife's pleasure. And he wanted to do that using tools that he was familiar with. And he was a Docker captain at the time, so it came naturally to him to try and do this using containers, which was quite a novel concept in 2016, doing serverless computing in containers. And it turned out that a lot of other people thought this was a really great idea. And he won a competition at DockerCon in 2017. And this is him presenting in the bottom corner at the closing keynote in front of several thousand users. Now, since 2017, fast forward to today, we've come a really long way. We've got many production users, big names like BT in the UK. We've even got banks that are running their home banking platform using OpenFaaS. We've won 2 industry awards recognizing this project. Recently, we got a BOSI in December last year. Now, how does OpenFaaS, why is it different from the other FaaS platforms out there? One is we're community-led, so there's no vendor backing, and so we're agnostic to what we run on. Even though Kubernetes is preferred, that's not the only platform you can run on. And we very much focus on developer experience. So it's all about simplicity, simplicity at the command line, simplicity at the API, and making it easy to extend. You can run any code. That doesn't come as a surprise. Windows binaries, ARM binaries, x86. Anywhere the Docker engine can run, you can run OpenFaaS. As I mentioned, anywhere, you can run on Kubernetes, Nomad, Fargate, and EC2, ECS, as well as some other platforms. And you've got a lot of flexibility about how you run your functions, how you scale them. We have sensible defaults out of the box, but if you want to customize those, you can. So you can choose to scale to 0, or to scale to n number of minimum replicas to avoid cold start times, if that's a use case for your business. And more importantly, we don't constrain you with limits. So some cloud vendor platforms, you're limited because of their system. So this is a DigitalOcean report, and it's telling us the 7 most popular languages running inside containers. All 7 of those are first-class languages in OpenFaaS. And it's very easy to add your own. So Eric, a couple of years ago, added support for Bash, Kotlin, and Rust. And we now have support for other languages like COBOL and Crystal, all the useful ones. So this is this really easy developer experience. This CLI will feel a lot like other good CLIs like Docker. So to create your function, you just do FaaS new, language type, name of the function, and we generate this scaffolding for you, where you can just put your code. We also manage vendoring of dependencies using the popular method for your chosen language. And then a simple command, FaaS up. It will build your function, it will lint it, run unit tests, all the best practices for your language. then it will send it to a registry and then deploy it to a gateway. So deploy it to the platform ready for execution and just return you an endpoint. And that's all in one simple command. So let's take a look at this very quickly. I'm going to show you how to create a little weather app. And it's going to tell us what the weather's like in Hamburg. Probably not that useful. But we could see, let's just take a look at how easy it is, though. So I've got a directory here. But let's take a look at the FaaS CLI quickly. So FaaS version will tell you, useful information about what backend you're talking to. So you can see here that we're talking to a Kubernetes backend. And if we do FaaS template store list, that shows you all of the language support that we have in the platform. So I'm going to create this new weather function using Go. And I'm going to specify the prefix eWilde. That's my Docker registry username. So if we then open that up in our favorite code editor of the day, which is currently Golang for me, you can see we've got this simple manifest file where you can add environment variables or secrets. And then inside here, we've got our handler, the scaffolding, which we're going to replace with some actual code here. So this is just going to implement our simple weather function. Now, I need to lint this because my automation tool doesn't do that for me, or else we'll get a build error. So if I then jump into the terminal, I could just simply do a FaaS build, pass in that manifest, and it's going to compile me a container. And we'll also run unit tests if I had any in the folder and do the linting that I mentioned. So I'm connected to a Kubernetes cluster, and we're going to see in a minute that there's nothing running there. So if I go and get my pods in the function namespace, where we're going to deploy that to, I've got no resources. In my normal OpenFaaS namespace, I've got the components of the platform, which we'll have a look at in a minute. So if I now deploy this, it's going to return me... Sorry? Is it too small? Sorry, I can't hear you. I can't. Can you change the resolution? Okay. You want me to change the resolution? I can't understand you, I'm afraid. Sorry. You have to speak louder. Do you want to do it? Looks okay to me. Can everyone see the screen okay? Yeah? Let's go. So we got this endpoint back. Now, because we're developer friendly, it's, you can use your favorite tools like curl, obviously. So we need to pass in the body. So we're going to pass in Hamburg. And because we've got the wrong resolution, that looks a bit awful. Okay, I don't think... Anyway, you can trust me, it looks beautiful on a normal computer, and you get this weather report. I could try reducing it a bit. But you could also invoke it using the CLI. So we support Unix pipes, because we're developer friendly. So you could pipe in London to that function, to that WeatherGo function. We'll get the weather report in London, which it looks like it's a much nicer temperature. We've also got a UI. So if I hop over to the portal and refresh, you can invoke the weather function through the UI, so we could see what it's like in New York. Oops, New York. And this isn't designed for HTML, so you get funny terminal output. And if we went back and had a look at our pods, you could see that we've now got this weather function pod running in our function namespace. Okay. So as I mentioned, our preferred provider is Kubernetes, but we support Swarm, Nomad, and Fargate. And we do this using the provider model, which is like a plugin model. And there's two important components in the OpenFaaS architecture. We have an API gateway, which presents a REST interface to clients that allows them to manage functions. And then we have the provider interface. And the role of the provider is to translate those concepts into objects that make sense for the platform you're running on. So if you imagine you're on Kubernetes, you need to run that function in a pod. In order to get to that state, you need a service object and a deployment object. So that's what the provider would do when it got the request from the gateway. And this is that contract written in Go. The transport is actually HTTP between gateway and provider, but everyone's chosen to written providers in Go, so we have an SDK to make that easy for you. So at the top here, we've got some kind of CRUD handlers to do create, update, delete, and function proxy just runs the function when it's asked to. And then we've got handlers to scale up and down, as well as a platform-agnostic way of managing secrets, and then a few health and information endpoints. So if you were to extend the platform and you wanted to add, let's say, Knative support, this is as simple as it gets, really. All you need to do is return a handler func, and in the green kind of commented text, that's where you would use your sort of provider-specific knowledge. So you'd call out perhaps the Kubernetes API and create a Knative serving object. So switching gears a bit and coming back to Lambda support for OpenFaaS, this is a tweet by Patrick Coulson, the CEO of Stripe, and he's frustrated here how difficult it is for restaurants to take bookings and payments. They've got to have like 10 iPads to run all of these different apps. And I think we've got a little bit of this problem in the function world. In that Amazon came first, probably they were designing Lambda before the age of containers, and they have their own constraints. But their deployment model is zip files. Now, I don't know about you, but in our development teams, we deploy Docker containers. You know, our CI/CD pipeline is all about Docker containers, GitOps, and pushing those into an orchestration platform. But then over to the left, we've got this second iPad, which we're using for Lambda functions. A similar story with routing. Lambdas all route differently. You've got to have API gateways. You can't use your service mesh that you might have deployed in Kubernetes. That's a bit of a pain. So you've got that sort of second iPad. And the way that you deal with logs is also potentially the third iPad. So it got me thinking, I wonder if we use OpenFaaS, we could get rid of at least two of these extra iPads, the CI/CD and the routing. But why would you even want to do OpenFaaS on Lambda? I think that's an interesting question. Not everyone is on Kubernetes yet, as crazy as that might sound. So they might be looking for a way of putting a sort of a cloud-agnostic shim between Lambda and their main platform. So that might be a use case for this technology. Or alternatively, you might be just trying to be more cloud-agnostic because you're thinking about multi-cloud scenarios. There's some things in AWS that you can't do without using a Lambda. Or perhaps you don't want to manage lots of infrastructure for your functions and you want to take advantage of Lambdas, bursting and free tier options. So there's some of the use cases. But I don't want you to go away thinking that OpenFaaS is all about running on Lambda. That's certainly not the case. So with Kubernetes, you get much more portability and control over various aspects of scaling, timeouts, what sort of memory you have on your host machines. We're going to take a look at some of those trade-offs in a minute. So how do we design support for Lambda? Well, it's following that same plugin model. So we just have a provider that we've imaginatively called FaaS Lambda, and we seal in some secrets using Kubernetes secrets objects so that the Lambda provider can talk to the Lambda service using the AWS SDK. And it translates those core concepts into Lambda functions. So that sounds simple. The tricky bit is the deployment, because we've got containers coming out of the OpenFaaS pipeline, but Lambda doesn't support those. It's only got zip files. So what we do in that provider, when we get the request, we download the Docker image, and then using an open source tool called Scopio, we extract all the layers. And then we have to create a shim between the OpenFaaS handler and the Lambda handler because they're slightly different. And then we have to move all of the library dependencies around because the Lambda format wants them in a different location. Then we zip it all up and we send it to AWS. So that was the kind of the nut to crack Invocation was dead simple. We just simply call invoke in the AWS SDK, marshal the request body and the response body, and we're sort of done. So these are those shims that I briefly mentioned. So at the top here, you've got your OpenFaaS code, and at the bottom, we just created a simple shim. And we've done this in all of the language templates. This is the one for Node. The sort of static languages were a bit more difficult. And because we want to get this in the hands of users, we didn't spend a lot of time on this. So at the moment, we're using a forking method, which was quite common in the olden days with Lambda. If you wanted to support other languages, you would just use Node to fork out to a binary. But later on, we're going to redo this, perhaps using the Lambda custom runtime or even recompiling on deployment. So I'm going to show you how all this works. I've developed a little function which goes and grabs TLS information and stores it in an S3 bucket. And when we invoke that, the gateway is going to pass over the request to the Lambda provider. It's going to execute it in AWS Lambda, put the results in the bucket, and then in step 2, we're going to go and fetch that file and cat it to the terminal. OK. So the first thing that I need to do is make sure that I'm connected to the right OpenFaaS. So if I do FaaS version, we should see that it's connecting, yep, that's right, to the FaaS Lambda. And if I go over here, you can see that I've got no functions running in my AWS account. So if I come up a directory, I'm just going to quickly deploy that function. And then I'm tailing the output of the provider here. And you can see it's now downloading that Docker image. And it should be extracting those layers. Great, it has done. And then it's repackaged it. So it's quite quick. And now if I use the Amazon CLI and list my Lambda functions, you should see that it's deployed it. Thankfully, it has. But you could also use the FaaS CLI to confirm that, indeed, we have got one function running. And we can now echo the cert signing information into that, which I've handily got stored here, if we're working. Try that. Oh, yeah. Now, I don't know about you, but I learned to tell the time using seconds since midnight 1970, which is why this has got this handy payload here, valid for. So what this function is doing... Oh, I've got ahead of myself. My apologies. We are doing the TLS information, aren't we? I got up at 3 o'clock this morning, and my brain is... So let's do that. Let's just echo github.com. And we're going to do a FaaS invoke cert info S3. And from a developer's point of view, they don't know that they're talking to AWS Lambda. So now if we were to list that S3 bucket, we can see that indeed that function has run and it's created that. Now, I think the Wi-Fi is going a bit slowly, so apologies for that. And we can run all of that in one step now. So this is echoing google.com, invoking the function, and then we're passing back the argument to the AWS CLI and catting the result to the terminal. Does that all make sense? Great, OK. Well, I'm just going to delete that function now. And just to show, like, we could list the pods in the Kubernetes cluster from earlier on, and you can see that we haven't actually started the cert info one there. It's still just got the weather app one. So the way to remove the function is just quickly do remove. And now if we go back to our Lambda UI, you'll see that we haven't got the function there anymore. OK, so that's running on Lambda. Let's just start that again. So we saw how we built a Docker container but then extracted it and deployed it to Lambda, all using the same interface. So this is that platform comparison that I think is quite interesting. With Lambda, you're sort of constrained to 3 gigabytes of system memory. And with OpenFaaS on Kubernetes, it's 12, but it's not 12 gigabytes, it's 12 terabytes. So go and find the biggest machine that you can, and that's as much memory as you can use in your function, essentially. So that could be important if you're doing machine learning or data science. It's the same story with CPU. With Lambda, you get 2 cores if you allocate more than 1.8 gigabytes of memory to your function. With OpenFaaS on Kubernetes, you can just go out and find the biggest machine available on the market. Timeouts are quite interesting. You could run your function for 290 years on OpenFaaS. We didn't get time to test that, unfortunately. But on Lambda, it's only 30 seconds, or it's 15 minutes, depending on how you do your routing. It's the same story again with the code limits. You're limited to a 50 meg zip file on Amazon, whereas on Kubernetes, it's pretty much infinite. And as I mentioned earlier, the cold starts. You can configure OpenFaaS and other Kubernetes serverless platforms to have like minimum replicas, which is really useful. But to make this worthwhile in the real world, we want to deploy most functions to Kubernetes and then kind of a few of them to Lambda. So we introduced this new component called FaaS Federation, and its job is to split that traffic using some sort of metadata or some sort of methodology. That component can also be used to split traffic based on geography. So you might have an OpenFaaS cluster on the East Coast and one on the West, but you want a single control plane for all of those functions. So that was the basic idea of federation, is like a single pane of glass supporting multiple platforms, potentially that geo-split. But it's quite early days with this component, and we're thinking like later on, based on the community feedback, we may do that routing based on more dynamic metrics like CPU availability or other capacity metrics. So in this second demo, we're going to take a cryptographic function which generates a web certificate, and that's quite CPU intensive. So that runs quite slowly on Lambda. It takes about 6 seconds with decent Wi-Fi. So we really want to route that on Kubernetes. So if you see that request come into the gateway, when it goes to the federation component, we examine some metadata down here, and you can see that it's tagged with the name of the provider that we want it to run on. And so it's going to go across to Kubernetes. But we've got this other function, so info, which we saw earlier on, and we want that to run on Amazon because it's fairly quick, it uses S3, and we want to use some of our free tier. So now we have a different annotation, and it's got Lambda written in it. So that's how the federator knows where to route the request. So just quickly show you how that works. So the first thing is we just need to export some command line variables to point to the right cluster. And if I do FaaS version, I should now see that we're talking to the federated cluster, which we are. Fantastic. And then I've got this manifest file here that's got those 2 functions, and it's got the 2 annotations attached to them. So now we can deploy this. Passing in that manifest name, it's going to do the Lambda one first. So we'll see it downloading and extracting again. And then it's going to go ahead and do the Kubernetes one. So if we call up those pods, we should now see that it's started to boot up the cert sign. And this is where we're going to do that. We're going to execute the cert sign. So we're going to ask it to create a certificate for example.com in this payload. Really not sure what's happening. Oh, dear. Let's not do that there. Why don't we do it in the UI where I can see what's going on? So here you can see that single pane of glass. We've got both functions there. And let's execute the if my touch bar automator works correctly. Yes. So there's that Unix epoch for how long the certificate's valid for. If we invoke it, you can see it was really quick. It was 0.2 seconds. And I've got this Kubernetes cluster running on DigitalOcean. It doesn't have to run on AWS to get this sort of multi-platform thing working. If we echo that out to the terminal, we can show that it's working. Let's send that to OpenSSL. Oops. X509, no outs text. And we can see that indeed that did create example.com. And we could also invoke the Lambda function, and that would execute on Lambda. So hopefully that makes sense. Okay, to sum up, we've got this technique now for supporting different platforms. It doesn't have to be Kubernetes and Lambda. It could be Kubernetes, Nomad, and Lambda. It really doesn't matter. You can have as many backend providers as you want. But you do get that same easy developer experience which OpenFaaS is famous for. In order to do this, we had to create 3 new open source projects. The FaaS Federation, there was an in-memory provider which we now use for testing of that router, and FaaS Lambda. So if you're keen to try this out, please do sign up to our early access program. We're dying to get feedback from users. As I mentioned, we will increase template support and make it more performant. That's sort of the next thing on the task list. And some of us are going to go to production with this and try it out in anger. I must mention my company again, or else they won't let me come to these wonderful conferences. So this is where I work, on all this lovely cloud-native technology. We're obviously hiring, like everyone. I'll just let you take a photo of that. So thank you very much.